Hello friends, hello student. Now we are going to see fourth method by which we can find out the order of reaction, that is a differential method. Okay, in differential method there are the two sub method by which we can find out the order of reaction. We will see that is not much complicated. We'll go for the first method, the first method of differential method by which we can find out the order of reaction. See here, the rate of the reaction are determined corresponding to the two different initial concentration of the reactant. What are that concentration? Concentration A1 and concentration A2. Okay, the plot of X against time t are constructed where X is the amount of a reactant which has reacted, or the amount of product which is formed up in the time t or up to the time t. Okay, at the same time t, the rate of the reaction is determined for the two concentration by drawing a tangent to the curve at that point and determining its slope. Okay, so how that is calculated? See, the rate of the reaction is determined for the two concentration by drawing a tangent to the curve at that point. Okay, and determining its slope. See, so what graph is plotted? X versus time t. This is what the graph we have. Okay, so after taking the different readings, what we are going to do? So this is what the initial concentration of the reactant A. This is a concentration of reactant B. Now see what happens. Okay. After taking the readings, what we are going to do? We are plotting a graph. Okay, the points comes like this for the first graph. Okay, so over there you are plotting the graph, you are getting line like this. Okay, so here the slope is equal to dx upon dt into 1. Okay, slope is a how you are going to find out the slope over here, that is y2 minus y1 upon x2 minus x1. In practice you are finding slope like this. Okay, so y2 means higher reading on y-axis minus lower reading on y-axis upon higher reading on x-axis minus lower reading on x-axis. Okay, in this way you can find out the slope. Similarly, you can find out the slope over here. So dx upon dt 2. Here you can find out the slope. Okay, so rate of the reaction is given by Kc raised to n. What is n? N is the order of reaction. C is the concentration of the reactant. Okay, the rate at a time t can be written as rate is equal to dx upon dt of 1 is equal to Kc 1 raised to n. Rate for this, see, dx upon dt 2 is equal to k into c2 raised to n. Okay, so these are the rates. So divide equation 1 by equation 2. Divide equation 1 by equation 2, you will get c1 upon c2 raised to n. Taking log of both sides, we are going to focus for this term. For all this method, we are focusing for order of reaction. So n into log of c1 upon c2. So rearranging this equation, take this log of c1 upon c2 to that side. What you will get? N is equal to log of dx upon dt1. Here it is, minus log of dx upon dt2. Okay, upon log of c1 upon log of minus log of c2. That can be written as log of slope 1 minus log of slope 2. Here it is slope 1, here it is slope 2, upon log of concentration c1 into minus log of concentration c2. By this way you can find out the order of reaction. Okay, this is what the one method. Okay, in another method, what we are going to do, or what we can do here, see, here it is. The rate of reaction is determined at two different times during the course of reaction. Two different times we are finding out. Okay, so at a time t1, dx upon dt of t1 is equal to k into a minus x raised to n. Now this is what the general rate equation they are giving here for nth order reaction. Okay, dx upon dt is equal to k into a minus x raised to n. K a minus x raised to n. Okay, now at a time t, it's a k into a minus x1 raised to n. At a time t2, the rate is dx upon dt of t2. Okay, so that is equal to k into a minus x2 raised to n. Divide equation first by equation 2, you will get this term, and we have to find out n. So to find out n, we have to take log of both sides. Okay, and after rearranging this equation, take this log of a minus x1 upon a minus x2 to this side. Okay, over here you can take this to this side. Okay, so what we will get, n is equal to, I am writing n to this side now, log of dx upon dt of t1 minus log of dx upon dt of t2 upon log of a minus x1 minus log of a minus x2. Okay, so dx upon dt1 is a slope 1, dx upon dt2 is a slope 2. Okay, remaining term will remain same, and this is how you can calculate the value of n. This is how you can calculate the value of n. Okay, these are the two methods, sub method of differential method. Okay, so in the first method, what we did, see, two different concentrations were there. Okay, now here what you did, it's at the two different time you are finding out the slope. At the two different time you are finding out the slope, and here at the two different concentration you are finding out the slope. Okay, now see, the rate are determined from the plot of x against t and drawing a tangent at a point corresponding to t1 and t2. The slope of the tangents give the rate of reaction. Okay, so this is what you have plotted the graph. Okay, so at a time t1 and at a time t2, you are drawing a tangent to the this line. Okay, whatever plot you have get over there, so you are just putting a tangent to the t1, here it is. Okay, and tangent to the t2. So here you can find out dx upon dt of t2 and dx upon dt of t1. This is what you are getting the slope. Okay, but how you are getting the slope? त्याला तुम्हाला काय करावं लागतं इथे y2 minus y1 upon x2 minus x1 करावं लागेल, and that way you will get the slope of that graph. Okay, so you are finding out slope at two different places. For the t2 here it is, for t1 here it is, and that values you are using here now. So this value you are using here, and this value you are using here. Okay, slope 1 and slope 2, and finally what you are getting, here it is, right? So it works. So what is the example for this method? See how we are going to use. The following data was recorded. So these are what the rates. In the first row, these are what the rates for set 1, set 2 and set 3. Set 1, set 2 and set 3 readings are taken. So this is a rate for set 1, of which concentration is 0.380. For the set 2, its a rate is 0.017, concentration is 0.190, here the 0.002, and here value is 0.09. Now we have to just enter the values by considering two sets at a time. Okay, see now rate of the reaction is dx upon dt. Barabar? So concentration of the reactant. So here is the rate and here is the concentration. Now solution. What is general equation? N is equal to log of dx upon dt1 minus log of dx upon dt2 upon log of c1 minus log of c2. See here. Getting my point? This is general equation. So we'll consider first set 1 and 2. So we have to just put the values. What is the value of dx upon dt1? Here it is 0.136. minus what is value of dx upon dt to 0.017. Put the values upon concentration 0.380 minus log of concentration log of 0.380 minus log of 0 minus log of 0.190 है ना. एकदा याचा log घेतलाय minus log of this value. So you get here value 3. N, what is the value? N value is 3. Now for second and third set you are doing same thing. What you are doing? You are taking log of this minus log of this upon log of this value minus log of this value. See, again that answer comes 3. Okay. Now for set 1 and 3, for set 1 and 3, so log of this value minus log of this value, okay, and log of this value minus log of this value. Okay, so you are getting again value 3. If you are getting 3 at 3 point, value of n as a 3, hence the order of reaction you can say as a third order reaction, as a third order reaction. So in this way we have not studied the third order reaction in this topic, but as our n comes as a 3, जर या तीनही ठिकाणी n is equal to 2 आला असता तर आपण काय बोललो असतो, ह्या रिएक्शनची ऑर्डर काय आहे, सेकंड ऑर्डर आहे. किंवा या तीनही ठिकाणी जर व्हॅल्यू काय आली असती 1 आली असती n ची, तर आपण काय बोललो असतो, या एक्झाम्पल मध्ये ऑर्डर ऑफ रिएक्शन काय आहे, फर्स्ट ऑर्डर रिएक्शन आहे. सो दिस इज ऑल अबाउट द method which is mentioned over here is a differential method. Okay, it has a 2 subtypes. Okay, पहिल्यांदा कॉन्सन्ट्रेशन कन्सिडर केले दोन वेगवेगळे, आणि नंतर दोन वेगवेगळ्या वेळी त्या ठिकाणी आपण कन्सिडर केलेले आहेत, आणि त्या बेसवरती आपण त्या ठिकाणी n ची व्हॅल्यू काढलेली आहे. ओके, थँक यू. विल सी रिमेनिंग इन द नेक्स्ट लेक्चर.